Find the exact value of the following using the sum and difference rule. Cosine of pi over 12. Here's the deal. I'm asking for the exact value. So if you throw this into your calculator and give it a decimal, that decimal is not the exact value. It's an approximate value because these values go on forever. So unless you're willing to write out every single digit, which will take you a while, then what I suggest you do is use these rules. The tricks of the trade are you should only pick numbers that are known values on the unit circle. So for part A there, we want to either add or subtract two angles on the unit circle and get pi over 12. So can anyone think of two angles such that when added or subtracted, we get pi over 12?
4 pi over 12 minus 3 pi.
So what is 4 pi over 12?
Pi over 3.
And what is 3 pi over 12? There you go. So 1/3 minus 1/4 is 1/12. You want to pick two known numbers on the unit circle, such that when you add or subtract them, you get pi over 12. There's actually infinitely many pairs. It's probably not so good. So for our problem, what's u? And what's v? So what we're going to do is we're going to be using the cosine of u minus v because we have subtracted. So cosine of u minus v is the cosine of u times the cosine of v plus the sine of u, sine of v. So all the u's become pi over 3. So all the v's become pi over 4's. So we're going to have the cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. Without looking at your unit circle, because everyone has it memorized, what is the cosine of pi over 3? Okay, 1/2. What is the cosine of pi over 4? Someone else. Radical 2 over 2 plus sine of pi over 3. Radical 3 over 2 times sine of pi over 4. Okay? Radical 2 over 2. We're going to have a common denominator here. What is our common denominator? What is our common denominator? 4. Good. So just add the numerators. So what's 1 times the square root of 2? What's radical 3 times radical 2? Radical 6. So what's radical 2 plus radical 6? Trick question. It's just radical 2 plus radical 6. You can't combine them because they're not like terms. So we're going to do the same thing for part B. So give me two angles that if you add or subtract them, you get 11/12 pi. Give me two numbers that add up to 11.
2 and 8.
3/8. What a really good specific example you just gave. So does everyone believe me that 3 pi over 12 plus 8 pi over 12 add up to 11 pi over 12? Okay. What is 3 pi over 12 reduced to? Pi over 4. And 8 pi over 12?
2 pi over 3.
2 pi over 3. Hooray! And that was a good use of the original numbers of 3 and 8 because we ended up with numbers that are on the unit circle. So our u could be pi over 4, our v could be 2 pi over 3. It does not matter the order in which you pick these because addition is standard. So if you pick the other way around, totally fine if it's the same. So we'll be using the cosine of u plus v formula. Technically, you do not have to write this down each and every time. How that works. If you're a tactile, visual person, you should write it down every single time. Have it on the top of your page. You see it. So put in pi over 4 for all the u's, put in 2 pi over 3 for all the v's. You're going to have a great time. Oh, I'm having so much fun. You should really charge admission for this. What is the cosine of pi over 4? Cosine of 2? What quadrant is 2 pi over 3 in? 2, and cosine is what letter? Negative. No. Negative 1/2. Because its reference angle is pi over 3. Cosine of pi over 3 is positive 1/2. Is it for quadrant 2? It's negative 1/2. Minus, what's the sine of pi over 4? Radical 2 over 2. Times sine of 2 pi over 3. Radical 2 over 2. Good. So all the denominators, just like before, will also be 4. That's a 9. So what's the numerator going to be? Negative radical 2 minus radical 6. Notice that it's just negative 1 times our answer from part A. What's the relationship between pi over 12 and 11 pi over 12? There's supplements. Yeah. Which means that the reference angle for 11 pi over 12 would have been pi over 12. this is in quadrant 2 of pi over 12. And all you have to do is